Yay! Okay, we're live. We are looking at substring searches, and in particular, what we covered up to now is a substring search if I know exactly what the pattern looks like. So, for example, I'm looking for the word main in a whole directory of Java files. Okay? I search for it. It's like Control F in MS Word. That's what we did up to now. However, what we did with Rabin-Cobb fingerprinting, with Boyer-Moore, with Knuth-Morris-Pratt, is the whole pattern is known. Yes? But we very often search with wildcards. Or you could imagine that in a research situation, a bioinformatics researcher might be looking for a genome sequence with gaps in them. I know what this part is, and then there can be anything, I don't really mind, and then the rest. For example, do you ever use the command line on Linux? Some of you do, or even in VI. If I want to, I'm remarking a project too at the moment. So did my Java thing, Java C, star.java, right? There was a wildcard. Then it came, when I ran the program, it said no main found. Oh my word. So main was in the main project file. Yes. So what I did was on the command line, I said grep. I said grep find main in any of my Java files, right? Have you ever used grep? Yeah. So you know what grep does. But I have a wildcard in the file name, but I could also have had a wildcard in that specific pattern that I'm looking at. And you often do that when you search, even in Excel, in Word. I have incomplete information. If I have incomplete information, there is no ways I can use Rabin-Cobb fingerprintings, because how do I hash? It just won't work. You might sort of be able to have this whole bowl of spaghetti in Knuth-Morris-Pratt or Rabin-Cobb, where you test the pattern against the wildcard or something, but what if the wildcard is not a single character, but any number of characters? Yes, like star.java. That star represents any number of characters. It could be a.java, ab.java, project2.java, GUI.java. It's not a fixed number of characters. So it won't work in that case, no matter how many ifs you try to put into Rabin-Cobb or Boyer-Moore or Knuth-Morris-Pratt, right? So we want to have a solution for this very practical problem. How do I search when I have wildcards, when I have incomplete information in my pattern? Okay. And this brings me to something which says, is there any way I can describe a pattern in a more general way? And the way we describe patterns is with a so-called regular expression. Sidestep quickly. In previous years, the first years did regular expressions, but now, so in the second year, I didn't repeat this section 5.4. But you did not do regular expressions, am I correct? It is absolutely essential in computer science. You know that next semester you're going to write a small little toy compiler. You need regular expressions, and you need DFAs and you need NFAs. Okay, so I am going to spend some time on regular expressions. Okay. Hopefully we can finish today, otherwise I'll finish on Thursday, because Wednesday is a public holiday. Yes, so I am lecturing on Thursday, for those of you who want to know. Right. So the idea here is the pattern matching is somewhat different. Previously, we had a text and we had a fixed pattern, and we were simply comparing the characters in the pattern against the characters in the text. Now we are going to look at this from a different perspective. Our perspective will be the following. I'm going to look at the pattern, and since the pattern contains wildcards, there will be more than one string that matches that pattern. For example, my many Java files, yes? Star.java can be matched by project2.java or by GUI.java. So I have a pattern describing many strings that may match this pattern. And then we say that the set of patterns, the set of strings that satisfy the pattern, that can potentially match the pattern, forms a set of strings. Yeah? So suppose I have only 2 Java files in my project2 directory. Yes. This, and it gives me GUI.java and project2.java. Yes. If I want to describe this with a regular expression, it would be a regular expression that would recognize any string of the form, any word, as long as it has finite length, .java. Therefore, this regular expression recognizes a set of strings. And in this specific case, of course, Star.java can recognize anything you want to write down .java, but in this directory, I have 2 strings that match, GUI.java and project2.java. And therefore, just in this directory, the language recognized by the regular expression is the set. Or if you want to, the language generated by the regular expression. So from now on, I'm going to talk about strings and regular expressions and the language. And the language associated with that regular expression is the collection, the set. It is a set. It is the set of strings that match that regular expression. Okay? Bit of terminology. Stop me if you want me to repeat anything. Okay. So what we are going to do is we are going to give a formal definition of a regular expression. For the moment, I'm going to ignore the top 2, and I'm just going to look at the rest of the definition. If you give me a single character from the alphabet, say I'm just doing the Roman alphabet with its 26 characters. If you give me a single character, that is a regular expression. And now this is a constructive definition. So if you give me, I can start with a single character, which is a regular expression. I can enclose that character or the current regular expression in parentheses, and it's still a regular expression. Yes, it's like an arithmetic operation. 3 plus 5 is definitely an arithmetic expression. If I put brackets around it, it's sort of a meta character to understand the semantics better. So that is still a regular expression. And then there are 3 ways that we can build up longer regular expressions. The first one is to concatenate. What does concatenation mean? Well, het iemand vir my los papier iewers? Empty piece of paper and a pen, because it works better if I write under the document camera. Sorry. Who's on? It's up there. Right. Are you done? Okay. So let's work through a few examples. If an alphabet character is a regular expression, I can say A is a regular expression. Well, suppose I have another regular expression, C. Yes? If I write those two next to each other to form the string AC, that is concatenation. Yes? Concatenation means writing things next to each other. And you must think of this concatenation in terms of substrings. Yes? So it's like, what's the Java operator? You concatenate 2 strings. Yes? Exactly the same thing. So the first operator that I have for regular expressions is concatenations. Concatenation. I also am allowed to use the OR operator, which gives me a choice. So if I have, again, regular expressions, now we have another one, so let's use that one. I can take any 2 regular expressions and I can OR them. And that gives me, again, a regular expression. And that regular expression says, the string that I'm going to try to match, right, is either an A or it is AC. Okay? And then there's the other one that's a bit tricky, the so-called closure operator, also known as the clean closure. I think that word is in the book somewhere. Clean closure, named after the guy who thought this up on a lazy Sunday afternoon. I've got the clean closure. The clean closure is indicated by a star. And star means, let's write down an example. Star means 0 or more repetitions of that regular expression. Right? 0 or more repetitions. Ignore the 0 for a moment. If I write down this regular expression, then this is a repetition of length 1. Yes? If I repeat it twice, I get that. If I repeat it 3 times, I get that, and so on. Yes? So that is repetition. The 0 repetition gives me something known as an empty string. And the empty string is written with a small epsilon like that. Okay? And if I repeat something 0 times, it means that thing is empty. So this is known as the empty string. And now I can come back to the definition of a regular expression. The empty string is a regular expression. Yes? So now you can give me any regular expression and I can use the start. I can initialize given regular expressions and I can build larger ones. Incidentally, this is a trick which I hope you're familiar with, which we often use in mathematics. So this is you give me an axiom and a set of rules. My axiom in this case is the empty string and the single character, and then you give me rules to make bigger ones. Have you done propositional logic in mathematics from a formal point of view? The whole of logic, where you can say and or and not and XOR and so on, starts like this. Give me any two symbols, alphabet characters like P or Q, called an axiom, and then I can either AND them or not them or OR them. Yeah, and there you have the whole of propositional logic, which is cool. So regular expressions look like that as well. Incidentally, this thing that I've now ignored, the empty set, it is possible to write down a regular expression that matches no strings whatsoever. Yes, so this set that we build in will be empty. It won't contain the empty string. It will simply, that set will be really the empty set. There are no elements, not even the empty string symbol. There are no elements in that set, and that is the empty language. Right. There are situations where we do use the empty language. Anyway, okay, so let's look at a few examples to make this a bit less formal. Suppose I have a language with A's and B's and C's and D's. I am writing in parentheses A or B concatenated with, because concatenation is just writing things next to each other, concatenated with either a C or a D. So this thing, this regular expression, if I write a string AC, it will match this regular expression. Why? Because here I choose an A and then I concatenate and I choose a C. C, yes. So any combination of AB followed by combination of CD, right? It does not match anything that is not AC, AB, BC, or BD. That's what is meant by every other string. Okay, so if I write cat, this regular expression does not recognize the string cat. Yes? Okay. Let's look at a bigger example. This one contains concatenation, the OR, and the clean closure. And again, concatenation. So there are four parts to this. First, it is A concatenated with. What is it concatenated with? The clean closure of the choice B or C, and that is concatenated with a D. Now, if you start reading this, you can see that any valid string would have to start with an A and end with a D. And then there's this thing in between, B or C closed. So any repetition of a B or a C in steps. So let's look at this one. I have an A, this matches. I have an A, I end with a D, I'm very happy. Is B, C, C, B in this set, B or C closed? Yes, it is, because this is any number of repetitions. This thing chose 4 repetitions. The first time I chose a B, the second time a C, the second time a C, the third time a C, the fourth time a B. Yes, does this make sense to you? You following this? And so on and so forth. You have to be very careful when you don't have brackets. Over here, you should read this as any number of A's followed by a B, followed by any number of A's, followed by a B, followed by any number of A's. And I can repeat this any number of times. And here are examples of strings that match and strings that don't match. Incidentally, if you think about it carefully, all this thing is saying over here is I must have 2 B's. And then I can have any number of A's in between in any order. So as long as I have an even number of B's, this regular expression describes the language with strings over the set AB, the alphabet AB, with an even number of B's. But why then this or a star? Because 0 is an even number. So if the string contains 0 B's, that's an even number of B's. Otherwise, it could contain 2 B's, it could contain 4 B's, 6 B's, 8 B's, and so on. Okay, so you have to play around with the exercises. Ask Google. Yes? For exercises on regular expressions, you have to get a feeling for this. It's like the first time you draw an DFA. You have to think about it a bit. This is, if you go to Stack Exchange, which in my experience is the second-year Bible, go look how many questions there are on Stack Exchange as far as regular expressions are concerned. You use it all the time for anything. Okay? Right. The book lists many examples. Okay, now we get to something. The definition of a regular expression is the one we have here. This is the standard one. We can use many shortcuts once you start to do real language processing. The first one we can use is a wildcard. It is indicated by a full stop. So A dot B actually means A, then any single character, then a B. Yes, so ACB, ADB, AAB, ABB, and so on. Yes, single character wildcard, I think. Depending on what version of, you probably never use the terminal in Windows, but anyway. Many systems also use a question mark to indicate a single character match. Okay, so this is the single character match. Sometimes you want to match any of a number of symbols. Like suppose you want to write a regular expression, and this is a lovely test question always. Write a regular expression that can recognize student numbers. Or write a regular expression that can recognize an integer or a decimal number, because compilers have to do that, right? You type in things in your .java file, and the compiler is a program that recognizes. Yes. Have you ever thought about how compilers work? Have you gotten a good answer? No. So this is how a compiler works. Okay, this is how a compiler works. You give it a .java file. Okay. The compiler reads your file, which is just a collection of text characters with no interpretation whatsoever. And then it makes a distinction, simply doing text character matching, whether it is looking at a string of characters, whether it's looking at digits, so it's a number, or whether it's looking at comments. To recognize comments is easy enough. You get either a double slash or you get slash star, and then you just ignore everything until the comment ends, or the end of the line, if it's a single line comment. So that you can do already. Why can't a variable name in Java start with a numeric digit? Because that's the way the compiler works. It makes the life very difficult for the compiler, because what the compiler program does is it reads, is this a digit? Yes, so it's the character 1. Yeah, there was a space or something, and then it's the character 1. And now the compiler writer wants to be lazy, so he says, well, the moment I recognize a digit, I assume it's a number. And then the compiler goes and reads the whole digit string, if you want, and converts it to a number, and now I have a number. If it is not a digit that you recognize as the beginning of a new string, well, then it's either a keyword in Java or a variable. Java has a finite number, a limited, very small number of keywords, while if, okay, when you get to objects, it becomes a bit more, but okay. Very limited number of keywords. Therefore, the compiler simply holds the strings in a table, and if it sees a string, it goes and checks if it's a keyword. If it does not find a match in the keyword table, it assumes it's a variable name. And then the compiler tokenizes your input file. What does tokenize mean? It means that it recognized the type of thing that was there. The string that I got before this, the string that I got was either a variable name, or it was a keyword, or it was a number. And then it tells the next part of the compiler. This is the order in which I got these things. And then the next part of the compiler is called the parser. It checks whether your syntax is correct. And all that parser is a DFA. Remember DFAs from last week. And it simply checks if things are in the correct order. So I have a keyword followed by a bracket, followed by an assignment, followed by... It just checks the order. It doesn't worry in any way whatsoever what it means. That is the syntax analysis, just checking the right order. I'm not allowed to write, give me an example. If, well, depends, I guess. Oh, if you have if and you have some sort of something, there must be a bracket and a Boolean expression close by the bracket and so on. So if instead of seeing if left bracket, I see if while, you get a syntax error. If I miss my semicolon, you get a syntax error. It just checks the order. It's a huge DFA. And then once you know what the order is of your Java program, you must check things we call semantics. That's like, did you declare all your variables and do my types match? I'm not assigning a character to an integer or an whatever, a float to an integer or something like that, yes? And then lastly, while recognizing the order, the compiler also does code generation, which means as I'm recognizing the order of things, it is possible to simultaneously say, generate the binary code for an if, generate the binary code for an assignment, whatever. Okay? So now you can impress Willem Bester next semester saying you know exactly how compilers work. Okay. Incidentally, this is a suitable time for a warning about 244. 114 and 144 are easy. 114 is just like trivial if you've programmed before. If not, you struggle a bit until you get it. Then 144, Henny got a bit more theoretical, but it just means I actually had to start doing something for computer science. Then you got this one, and I'm sort of very, you know, casual. if you read the book, you get there. It's not a difficult subject to pass. But in 244, that is the absolute final hurdle before you get to CS3. And Willem Bester is pedantic. You know him. You have him for VB2, right? There's nothing like, oh, I forgot to attach the plagiarism form, even though I knew I had. Oh, I know I was supposed to use Git, but I don't like Git, so I just somewhere emailed you. There's nothing like that. So please be aware that next semester you will work harder than you have ever in your whole life worked in computer science. Also know that if you pass the subject, you're actually cool. You can start working for Google or Amazon. Not really, you know, not enough theory by that time, but you're good, okay? But be aware of it. Be extremely careful. Follow all instructions 100%, otherwise you will die. Okay, but you may now impress him and say you know how compilers work. Rather say you don't, and then he re-explains it, but okay. Right, so shortcuts. Normally, how many of you use VI or Vim? I, okay. Normally, when you search, okay, you said you do grep as well. So if you really do non-trivial greps, the thing you give to grep may be a regular expression, right? And sometimes it becomes convenient, depending on the application, to use what is known as extended regular expressions. Extended regular expressions gives us some shorthand descriptions. For example, I can define ranges. Now you can see immediately how useful this is. Suppose I tell you to write down the regular expression for integers. Yes? Then you would have to say 0 or 1 or 2 or 3 or 4, blah, 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 right over 2 lines. So it's much easier if we can actually define ranges on the ASCII table, if you want to, okay? Similarly, we can also specify a specific set. For example, all the vowels. Yes. So if I want to, yes, Mr. Wolf.
Question, why does star specify 0 more elements? Why does it match the empty?
I'm trying to think of a good practical example. The vending machine that we talked about when we did DFAs. We want to say that if I'm in the neutral state, that is an acceptable state. So if the start state of the DFA is an accept state, that represents the empty string. I cannot, here's some more text languages. Give me, oh, no, sorry. From a text processing point of view, it actually doesn't make sense. But the other example, suppose I want to have a look at known patterns such as the regular expression that contains an even number of b's. I need that 0 there. There are some patterns that should contain 0 or more. So an even number of b's, for example, would be 0, 2, 4, 6, 8, 10. Okay. We also have complement. If you just be careful, if you have a complement, which is represented by the caret, if you have that inside a range, it means none of these. Okay, right. So what I expect you to do is I expect you to get a verbal description, and you must be able to write down the regular expression. I expect you to, given a regular expression, identify whether a certain string matches that regular expression. Okay? It's not as easy as it sounds. So please, 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 this is like riding a bicycle. Please look at many examples. Yes? Please work through the exercises. Okay? Oh, here's another one. A specific number of. So this thing says, I want exactly 3 occurrences of the string A, B next to each other. And so on and so forth. Okay? Right. Now, why on earth am I carrying on about the regular expressions? Well, you are using it every day. You actually need this every day when you write code. For example, have you ever been on a website? I hope you have many times been on a website where you were supposed to type in your email address. Yeah, you enter a competition, you register at Take-A-Lot, whatever you do on the web. And then the system comes back and says, invalid, please type in a valid email address. How the hell does it know it was invalid? Because there's a regular expression that matches valid email addresses. For example, if I were to have a website and I want a valid Stellenbosch University, meneer Eis, a valid Stellenbosch University email address, I would check that it is a sequence of numbers of the correct length, followed by the @ sign, followed by sun.ac.za. Yes? Okay. So you use this, whether you're doing web design, whether you're writing compilers, whether you're doing text matching, it is all over the show. Okay, read through the applications, use it in grep, use it in searches, and so on. But we cover this in detail in your honors year. Not all languages can be specified with regular expressions. Try and think how you would write a regular expression for English, for the English language, any valid English sentence. Suppose I really like good grammar. So you'll see in your report that you have lots of red simply on the grammar, never mind the content. You cannot do that. It is not possible. Here's another. I was talking about a compiler. One of the things in a compiler is the arithmetic expressions. Yes? X plus y times 5 divided by 7 mod 2. And there will be brackets. And one of the things that clever systems do, or a compiler does, is it tells you, I need an extra right bracket. The brackets are not balanced. Regular expressions cannot do that. And the reason being that, think back to DFAs. DFA is a state, an event happens, and I go to the next state. Once I am in that state, I have no idea how I got there. So DFAs do not have any memory whatsoever. If you want to do something like match brackets, you have to remember how many brackets have I had up to now, which bracket am I matching? Another example, so you would have to remember your brackets, as it were. And it's easy to do that if you use a stack in conjunction with your finite automaton. So as your DFA goes through the string, whenever you get a bracket, you push it on the stack. Yes, left bracket. And as I get my right brackets, I just pop the top of the stack. And when the stack is empty, my brackets did match. Same example as palindromes, things that read the same from the left to the right. Yes? Like ABBA. How many of you listen to 70s music? I don't know, there are lots of examples. Okay, so regular expressions, although they seem extremely powerful, and they are such nice handy tools, especially in programming, because in programming, you have very restrictive rules on the types of sentences, strings that can occur. Regular expressions recognize what is known, a class of languages known as the regular languages. Go read up on it, it's totally fascinating. Okay, so how do we handle regular expressions programmatically? Because what we are interested in is that job at Google where I actually ace the interview, right? So the whole idea about regular expressions is that they are useful in computer science applications, okay? So if that is the case, it's all fair and well to know about regular expressions, but I have to be able to program it in Java. Yes? So how do we handle regular expressions and string matching with wildcards in Java? That's the whole point. If you want to, you can go back to your first year book. If you really want to do this for a competition, those of you who do competitions, there are standard libraries in Java to do this. So you don't have to recode it every time. But, of course, you have to know how the libraries work. So what we are going to do is we are going to represent the regular expression with a finite automaton. Now you already know about DFAs, so now we introduce the next kind of finite automaton called a non-deterministic finite automaton. Let's just look at the picture. Not a good picture. Oh, okay. Let me draw this. A DFA has a start state. And then events can happen, and if an event happens, we go to the next state. So, for example, my vending machine, I put a coin in the machine. Now I'm in a different state, and then another event happens. But one of the things we said is it is deterministic. So, the event that happens must be unique for that given state. So if I am, this is a non-deterministic machine, if the user enters a coin, this machine can either go to state Q1 or to state Q2, non-deterministically. My husband calls it the female automaton. Apparently, you never know what we're going to do next. So, right, is everybody awake with that joke? At my own expense. Right. So this is the, as far as you are concerned, it's not strictly true theoretically, but the main difference between DFAs and NFAs is that with an NFA, we give a non-deterministic choice on what we're going to do next. Yes? And here is an example of a regular expression and its corresponding NFA. Right? And how we're going to handle it is that we are going to take all these, what we call meta characters, yes? And if I'm in a state, on a red arrow, I go to the next state. On the red arrow, I go to the next state. And every time we hit an alphabet character. That means that alphabet character is in the string that I'm trying to match. Back step. You have meta characters, which is not part of the final string, yes? So star is a meta character, yes, but it's replaced by real characters, G and a U and an I. So those are the characters in the string that we're trying to match. So the only characters that we're trying to match here are A, B, A, C, and D, but there are many other characters in the regular expression. Yes? So given the regular expression, we build an NFA with two kinds of arrows. Every time I hit a character match, I make a black arrow to the next state. If it's a meta character, I get a red arrow. Okay? And these two things are just next to each other, so brackets are easy. A star, if I get to a star, I must have a red arrow that goes back to the character because I'm trying to repeat that character. Yes, so I have to go to that, back to that state. Okay. If I have an OR, I have this funny thing. The OR is there, you see, in state 5. And if I hit the OR, I could either have done the part before state 5 or the part after state 5. Okay? And therefore, I can either go to AC or I can jump to the end of this whole thing there. So I'm coming in with AB, A star B, but it is also possible to jump to AC on the if. Okay, right? And if I hit this bar over here, the choice, it means I can only get there once I've read AB. So I'm not allowed to do the AC part. So I jump over it, Mr. Woolman.
That requires a little bit of pre-processing, because how would you jump back to state 1 to point that arrow?
Exactly as with Knuth-Morris-Pratt, how do I construct this automaton? And what we're going to do on Wednesday is we're going to look at the Java code to construct the automaton, given the regular expression first, and then second, how do I simulate? Once I have this DFA, how do I match the string? Okay, and then we're finished with 5.4. Great, I'll see you on Wednesday. Thursday. Sorry. Please be here on Thursday, if you can. Make an effort. Juffrou Coetzee.